In data mining, I use the CRISP-DM methodology as a structured approach. It consists of 6 key steps. Business understanding. I start by clarifying the business objectives and defining how data mining will address these goals. Next is data understanding. At this point, I would explore the data, assess the quality, and identify any potential issues or patterns that might influence analysis. Then is data prep. This step involves cleaning and transforming the data, ensuring it's ready for modeling. It's important to handle missing values, normalize data, or combine data sets when necessary. Next would be modeling. Here I select and apply the appropriate models such as regression or classification to the data set. I typically split the data into training and testing sets to evaluate model performance. Evaluation is when I would assess the model's accuracy and ensure it aligns with the original business objectives. If necessary, I refine the model or revisit earlier steps. And final step would be deployment. The model is implemented and the results are communicated. Ongoing monitoring is important to ensure long-term effectiveness and accuracy at this point. Before forecasting a time series, I start by thoroughly analyzing the data to identify key patterns, like trends or seasonality. I also check if the data is stationary, meaning its statistical properties remain constant over time, which is often a requirement for many forecasting models. If it's not stationary, I use techniques like differencing or log transformation to make it so. After that, I select an appropriate forecasting model, whether it's ARIMA, exponential smoothing, or another model, and then test its performance using historical data to ensure accurate predictions. So if I notice potential bias in how a model was measured, I'd gather data or examples that demonstrate the issue. I would then approach my manager with specific evidence explaining how the bias could impact the model's predictions or the fairness of the results. For example, if a certain group was underrepresented in the data set, it wouldn't skew predictions. And to avoid this in the future, I would suggest introducing fairness checks at each stage of model development, use more diverse training data sets, and implement regular bias audits. It's important to establish clear metrics that go beyond just the accuracy and include fairness and inclusivity as well. The key principles of data ethics that I adhere to include fairness, transparency, privacy, and accountability. Fairness ensures that data and algorithms are free from bias. Transparency involves clear communication about how data is being used. Privacy protects personal information, and accountability means that those handling the data are responsible for their decisions and actions. To uphold these principles, companies can conduct regular audits for bias, implement strong data governance policies, and ensure all stakeholders understand the ethical implications of data usage. Establishing ethical oversights committees and offering training programs on responsible data handling are also an effective way to uphold those values. Regression and classification models serve different purposes. Regression models are used when the goal is to predict a continuous outcome, such as predicting house prices based on various factors. Classification models, on the other hand, are used to predict discrete categories, such as whether an email is spam or not. I would choose regression when predicting a numerical value, and classification when the output needs to fall within distinct categories. For example, if I'm trying to forecast sales numbers, I'd use regression, but if I was building a model to classify customer feedback as positive or negative, I would use a classification model.